Close attention to example 7. Okay, important.
You may read this on your own 10 times, you still cannot understand. So please pay attention.
Show that on the curve, or with this equation, y cannot take values between two limits, which are to be determined. Okay, don't copy. Don't copy the graph, please. Okay, just listen, look up, look up, look up. When I say look up, yeah, never mind. It's okay. I've been scolding my son over the weekend, so I always ask him, look at me, look at me, look at me. So it feels like, whoa. Okay, anyway.
You are trying to prove that y for this curve cannot take on two values, between two values to be determined. What we are saying is this. To solve this question, there's no need to sketch the graph, I said it before, but I just want to sketch it for you to understand.
You look carefully. Y cannot take on this value because this horizontal line doesn't cut the curve. Do you follow what I'm saying? Your job is to find out what is this value and what is this value. Between these two values, actually, y cannot take between these two values. Do you follow what I'm saying? Your job is to find out what are these two values. Can, right? But how lah? The problem is how lah. Okay, never mind. Suppose this. Let's suppose this. Let's look at our equation here. Let's say y equals to 5. How do I find the x coordinates of these two? I substitute y equals to 5 in, correct? Then I cross multiply, I get a quadratic equation x. I solve the quadratic equation, I get two values of x, I get these two points. Am I right? If I get another y equals to 6, I will do the same thing, cross multiply, and then I get a quadratic equation x, solve the 2x. Now, if I put a generic y in, I get this quadratic equation and this quadratic equation x. I still can solve x and y. It's just that now y can be anything, can be 5, 6, 1 quarter, whatever. Now, in order for me to have some intersection point, I must be able to solve this and have solutions in x. Am I right? In order for me to have some intersection point, I must be able to find an intersection point. I must be able to solve this thing, have real solutions in x. Am I right? How do I obtain real solutions in x? Real solutions of x. The discriminant must be greater or equals to 0. That's why I say you read 10 times on your own, you also cannot understand. Okay, the rest is easy because you say, oh, discriminant greater or equals to 0, okay, b square minus 4ac greater than 0, solve. You realize that your y, find out what this means. This means that, I'm going to say in words, I'm not going to write down. In order for real solutions of x, y must be greater than 1.5 or smaller than 1.6. Let's go back to the graph again. That means y must be greater than 1.5 in order for me to cut the curve, or must be smaller than 1.6 in order for me to cut the curve. So then what are the two values? What are the two? Let's answer the question. Y cannot take values. What are the, between the two limits? What are the two limits? 1/6 and 3/2. So the two limits which we wanted to find in the first place are y will only take values between 1/6 or at least 3/2. Therefore, y cannot take values between 1/6 and 3/2. Up to you.
A question here. Should you just put discriminant less than 0? Fine, you could have. But you will still get the same thing because the limit is still 1 over 6 and 3 over 2. 3 over 1. Okay? Alright? Okay. The graph is not part of the solution. I just want to highlight something when in the use of GC. The use of GC. Look here, this portion, highlight here. The GC will really give you this. Does the graph actually look like this? Not really. The graph actually looks like this. The graph actually looks like this. So you don't believe what you see on the GC. Oh, it looks like this. Okay, go inside, just draw. Just people. The graph, you must zoom in a little bit more. Just okay. All okay? Good. Okay. Symmetry.